Hello, in this video we have a function given by 2x squared minus 10x plus 6, and we want to restrict its domain to make sure that the inverse exists, and then we want to find the inverse and state the domain and the range of the inverse. So let's begin by looking at when this function is one-to-one, so we can make sure that we can define its inverse. The function f that we are considering is a quadratic function. It has positive concavity, so it's a parabola with positive concavity. So we want to find the vertex because that's a value where we are not going to be able to pass. Otherwise, we are not going to have a one-to-one function anymore. So I don't know exactly how the parabola looks like, but if the parabola is like this, the axis somewhere. Everything is going fine up to the point that we get to the vertex. Once we get to the vertex, we need to stop because the function is not one-to-one if we keep extending the domain. So we need to find what is the vertex of the function f. For that, we are going to use the formula that the x-coordinate of the vertex is given by minus b over 2a, and then, well, if we needed to find also the y-coordinate of the vertex, we'll need to apply the function to that value. So in this case, we have that a is 2 and v is negative 10. So the value of k, the x-coordinate of the vertex, is given by minus negative 10 divided by 2 times 2. So that's 10 over 4. So that's 5 over 2. So that's the domain for our function to be one-to-one, so we can make sure that the inverse exists. Now we need to find an expression for that inverse. So we have that y as a function of x is given by 2x squared minus 10x plus 6, and we want to write x as a function of y. So we are going to change the names of x and y, so we want x to be equal to 2y squared minus 10y plus 6, which we will also write as 2 as common factor, and then y squared minus 5y plus 3. Now, if we want to isolate y from here, we cannot just do it by moving things around. If we were able to do that, that would mean that we could solve a quadratic equation without a quadratic formula. And in general, that's not something we can do. So what we are going to do instead is to complete the square for the expression y squared minus 5y plus 3, because then we would be able to isolate y as we wish. So completing the square, we have here y squared minus 5y plus 3. We are going to write it as y minus something square, and then possibly we are going to need to sum something else. So what do we need inside the bracket? We need to have 5 over 2. So when we expand y minus 5 over 2 square, we'll get y squared minus 2 times 5 over 2 times y, so minus 5y plus 25 over 4. So we have 3 that we had in the original expression minus 25 over 4 to cancel the 25 over 4 we have inside the brackets. So that means that x is the same as 2 times y minus 5 over 2 square, and then let's simplify over here. 3 minus 25 over 4, that's going to be the same if we use common denominator for us 12 minus 25 over 4, so minus 13 over 4. Expanding inside the bracket, we have that x is equal to 2 multiplying the bracket with y minus 5 over 2, all of that square, minus 13 over 2. So that means that x plus 13 over 2, all of that multiplied by half, is equal to y minus 5 over 2 squared, which means if we take a square root on both sides, that y minus 5 over 2 is going to be either plus or minus, we have to decide that, the square root of a half times x plus 13 over 2. So y is 5 over 2 and then plus or minus. We have to check which one is the one that we want. And then square root of, I can expand a little bit and rewrite this as 2x plus 13 divided by 4. Now we need to decide which one of the options we want for the square root. If we want to take 5 half plus the square root or 5 half minus the square root. And maybe here at this point it's good to go back to the picture we have, or maybe even make a better one. So let's see what we know about the function. We know that the y-intercept is at 6, and we know that the vertex has x-coordinate 5 over 2. And we can see that the function does take some negative values because, for instance, we can look at the value of the function when x is equal to 1. That's easy. We'll get 2 minus 10 plus 6, so that will be negative. So that means that the vertex is going to be on the 4th quadrant. So we are going to have x-intercept. So the function is going to look like something like this. Now we only want the part of the function that is for the domain up to 5 over 2. So we only want the part that I'm marking with yellow. And we can imagine the line y equals x. And we can imagine that we take the reflection of our parabola and restrict it up to the x-coordinate of the vertex with respect to the line y equals x. We just need a few points for that. We have the point that stays fixed at y equals x. We have then that the vertex is going to correspond to a point, let's say over here, with negative x-coordinate and y-coordinate 5 over 2. And then the point 0, 6 is going to correspond to the point 6, 0 over here. So with those pieces of information, we can try to sketch the graph of the reflection, that is the graph of the inverse, and it's going to look like something like this. It's not a very good picture, but it's just a sketch. But what we see is that from the picture, the square root that we want is the one with negative sign, because that's the one that's going to have the shape that we need. So that means that the inverse of the function f is given by 5 over 2 minus square root of 2x plus 13 divided by 4. Now that we have the definition of the inverse function, we like to state its domain and range. So let's write what is the domain of the original function f. Well, we consider the function f restricted to x less or equal than 5 over 2, so the domain is from negative infinity to 5 over 2 included. And then the range is going to be given by the y-coordinate of the vertex included, and then going all the way up to positive infinity. So at this point, we realize that we do need to find what was the y-coordinate of the vertex. So we need to find, we're here, we need to find what is the result of applying the function f to 5 over 2. So we need to do 2 times 5 over 2 squared minus 10 times 5 over 2 plus 6. And this is 25 over 2 minus 50 over 2 plus 6. So minus 25 over 2 plus 12 over 2. So sorry, I'm running out of space. Negative 13 over 2. So that's where the range of the original function starts, and we need to include that point. Now to write the domain of the inverse function, the domain of the inverse function is going to be the range of the original one. So it's going to be from negative 13 over 2 to infinity, including the starting point. And the range of the inverse is going to be the domain of the original function. So the interval from negative infinity to 5 over 2, including the point 5 over 2.